Why is 4:30 in the morning like a snail shell? They're both too early. Well, I think 4:30 is too early.
The reactions button doesn't give us appropriate symbols.
Sorry. All right, it's 1 o'clock here in Eastern Time, so we're going to get started. Welcome to the second half of this session. And our next speaker is going to be Tim Pearce, myself, talking about acid rain and the decline of the tiger snail in northeastern North America. Hello, I'm Tim Pearce at Carnegie Museum with a presentation for you. Today I'm going to be talking about research that I've been doing with Nathan Brower and Heather Halton Van Tassel on the decline of the tiger snail, Anguispira alternata, in northeastern North America. The genus Anguispira are relatively large snails. The genus is endemic to North America. Anguispira alternata in particular is widespread, it's large, and it's common. And consequently, many museum records exist. It has been declining though, and acid precipitation was suggested as the cause of the decline for Pennsylvania 4 years ago in 2016. So today, I'm going to test the acid rain hypothesis by expanding from 1 state to 26 states in the northeastern United States. And in case you think that you might have heard a similar talk in the past, what's different today is that I have many more records, and we will be considering search effort and soil calcium. So these maps show how many counties are reporting Anguispira alternata in before 1960, the blue counties, and then after 1960 in the right, the blue counties also. As you can see, there are fewer counties reporting Anguispira after 1960 than before, and in fact, it's on the order of, it's less than 50%. So it does appear that there has been a decline. But is the decline real? And when I first saw these maps, I thought to myself, well, maybe the people after 1960 just aren't looking hard enough. So let's take a look at that. This bar graph shows the number of records of all species of land snails, not just Anguispira, but all species of land snails by decade. From 1890, when we started having good records, up to 1980, it looks like the number of records per decade, it fluctuated between about 3,000 and 10,000, but averaged around 5,000 records per decade. But then starting around 1990 and going into the 2000s and 2010s, the number of records shot way up. So it's ranging from 10,000 to 23,000 records per decade. So if the number of records is any indication of search effort, I would say that the people, at least since 1990, are not only searching hard enough or as hard as before, they're searching even harder. So I don't think that the decline can be attributed to a lack of search effort. But wait, there's another way that we can get at it also. See on each of these bars, there's a little slice of red at the top. So the blue part of the bar is the non-Anguispira land snails, and the red part of the bar are the Anguispira alternatas. Now it's a little bit hard to see how large they are. So here I have reproduced the percentage of that bar that is Anguispira in this lower graph. And so you can see between 1890 and about the mid-1900s, the average percentage of Anguispira was in the order of 5%, ranging from what, 4 to 7%. But after 1950, or the 1950s up into 1960, the percentage went down to around 2 to 4%. So that that decrease in the percentage of Anguispira suggests that it's a real decline, not anything to do with search effort. But so, for example, if you look at the 1930 bar, the 6% of the snails in the 1930s were Anguispira alternata. So if you collected 100 lots of Anguispira, or sorry, 100 lots of any species of snail, 6 of those would be Anguispira. But if you look in the 2000s, for example, of those 23,000 lots, only 2% were Anguispira. So again, if you collected 100 lots of snails, only 2 of them would be Anguispira. So something real has been happening. There really is a decline. So here are the 2 maps that I showed you before 1960 and after 1960. And I'm also showing you an acid rain map. This is the oldest acid rain map I could find from 1985. And the red areas are those that have experienced more serious acid rain, and the greener areas have had less serious acid rain. And you can see that a lot of the acid rain is there in the eastern part of the northeastern United States, and that's where a lot of the land snails have declined. So what I'm going to do is I'm going to take, for each county, I'm going to give it a score for how serious its acid rain was, and then we're going to make a prediction. If the county had more serious acid rain, I predict that there's a better chance of the snail disappearing from that county, whereas if the county had less serious acid rain, then there would be less chance of it disappearing in those counties. So let's take a look. Oh, but wait, first, we have to account for search effort. For example, what if nobody looked in the county after 1960? If nobody looked for any snails at all, then of course they didn't find Anguispira alternata, and so it might get scored as a disappearance. But that's completely unreliable. You can't say that it disappeared, or you can't say confidently that it disappeared just because you didn't find it if you didn't even look. So how many records would be necessary to actually find the Anguispira in a county if it were really there? So I looked at counties that had at least 10 records, and 50% of those counties had Anguispira alternata. I looked at those counties that had 50 records, and 80% of those had Anguispira alternata. If you wanted to get up to 95%, you'd have to find a county with 118 records. There were fewer counties that had that many records. So I'm going to go with counties that had at least 50 records and an 80% chance of actually finding Anguispira alternata. So for this analysis, I'm going to include counties that have at least 50 records after 1960. And if those counties have Anguispira in them after 1960, I will score that as persisting. And if Anguispira was not found after 1960, I will score that as having disappeared. So this map shows the counties where Anguispira disappeared in red, and the counties where Anguispira persisted in blue. And you can see that most of the counties where Anguispira disappeared are farther to the east. Well, that's pretty interesting. So if we take a look at the acid rain map, the acid rain was more seriously acidic in the farther to the east, and that's where a lot of the Anguispira were disappearing. And in fact, if you look at the if you look at those counties, the counties where they persisted averaged around 3.8 on this hydrogen ion kilograms per hectare scale. So 3.8, and the counties where they disappeared averaged around 4.5 on the hydrogen ion scale, and that difference is significant. So where there was more acid rain, the snail had a better chance of disappearing. So that result is consistent with acid precipitation or acid rain being the cause of the decline. Now, the astute people there in the audience might be saying, hey, but what's going on with Ohio and Indiana? So Ohio has no declines at all, but if you look at the acid rain map, it's got some serious acid rain going on. So what's going on with Ohio and Indiana and even Kentucky to some extent? But let's take a look at calcium. So this calcium map, this is mapping soil calcium in the top 5 centimeters of the soil, and we're giving the weight percent, the percentage weight of calcium in the soil. And if you notice there, there's actually more calcium in the soil farther to the west. And so, in fact, that might be what's going on with Ohio and Indiana, that they have more calcium in the soil. And so the calcium might be buffering the effects of the acid rain, or allowing the snail to persist better, to deal with the acid rain better if there's more calcium. And so, yes, in fact, there is more of the counties had snails persisting when there was more calcium than when the counties where the snail disappeared, and that was also a significant difference. So calcium is definitely an important factor there in helping the snail to persist. Now, given that humans have done a pretty good job of cleaning up our acid rain, these two maps show acid rain in 1985 and then acid precipitation in 2012. So we have been cleaning up our acid rain. And so you could ask, could the snail populations recover? And yes, that's definitely a possibility. But what acid rain does is that it washes out positively charged ions like calcium. And so it will take some time for those calcium ions to replenish, at least decades, possibly centuries. But I do expect that the snails will be able to recover at some point. So in conclusion, Anguis bower alternata populations have declined. There was a greater decline where there was more severe acid rain. There was actually less decline where there was more soil calcium, which might be because of buffering. And I also want to point out that museum data were very useful for addressing interesting questions, these ecological questions and others. So thank you very much to the many museums who have given us records, snail records, and to the many people who have helped us compiling the data and producing maps. I also want to point out that the Clean Air Act of 1970 did lead to reduced acid rain. So thank you very much. I think there's some time for questions.
Questions for Tim?
Somebody asks about, Marty Meyer asks, what's going on in Maine? There was a lot of decline there. And that's a good question. I don't actually know for sure. There was some acid precipitation there, but they also have relatively little calcium. So I suspect that even though the acid rain wasn't the most serious, it could be that acid rain combined with very little calcium could have led to their decline. I also have some speculation that possibly the calcium map that we see now could actually have been influenced by the acid rain. So some of the areas that had more serious acid rain sort of coincided with low calcium, and I wonder if that's because if they had more calcium previously, it could be that some of it has been washed out, leading to calcium depleted soils now.
That's what I think partly related to this other question. Are there other factors like habitat loss due to industrialization that could co-vary with acid rain and contribute to decline in snail populations?
Yeah, I've thought about that a lot. So agriculture and urbanization, things like that. But I don't think that those are a factor in the decline of the snail because the places where I look for it are in good woods. So I'm sure maybe there used to be a lot of good woods, but now if the good woods have been confined to a small area, that's where I look. So I don't think that the urbanization and the agriculture is responsible for the decline that I see.
And then I think Steve was posting a related question. How about indices of urbanization? Is it possible to incorporate those?
Yeah, again, I think that that's related to what I just said. Unless you look at what would be the I don't know, the reservoir effect. So if you have a large area of forest, then it's easier for the snails to maintain their populations, whereas in a smaller area. Even though it's still forest, it might be harder for them to maintain their population. That's the only thing that I can think would be relevant.
Okay,